Hello and welcome to another video. So in this video and over the next few weeks, I'm going to be doing something different. I'm normally doing the daily problems, but instead I started using this program called Zero Track, and I'll link it in the description. And what you can do is you can give it ratings of problems, and then it'll give you problems for that rating. So I'm just going to do all the problems that are 2000 ELO and higher, and then eventually we'll just do like the hardest ones. And I've done probably about half of them already, maybe. So if I've done the problem, I'll just skip it. So I've done some of these, and then this is the one I'm currently on. And yeah, there's like 500, and I've probably done 200 or something. So there's gonna be like 200-300 total, and then yeah, hopefully at the end we have done all the hardest. Like these are all Q3, Q4s, so it'll be interesting instead of doing the daily problems that I've done like 5,000 times. So yeah, all right. So and I'm gonna try to do these live so you can see how we do. Okay, so in this thing, you have Alice and Bob playing a game. String num of even length consisting of exclamations. On each player, you will do something. Choose an index. Replace it with a digit. Game ends when there's no more exclamation. Alright. So for Bob, the sum of the digits in the first half must be equal to the sum of the digits in the second half. Alice sum is equal. Okay. For example, this Bob wins because 2, 4, 3 is 8. Okay, simple enough. And yeah, this also goes to show like some of these are going to be marked mediums, but they're going to be harder than some hards. So yeah, I mean definitely once we get to like the hard enough ones, they'll all be hards. But yeah, we'll get some of the toughest mediums as well. Okay, and we'll see if some graph or DP or anything is overinflated just because it's graph and DP. So assuming they'll play optimally, return true for Alice or win Bob. Okay. So here, there's no more moves, so Bob just wins. Here, so okay, so yeah, Alice can just replace a thing with a 9. All right. So let's look at this one. This is kind of an interesting one. So if we have this, like let's figure out kind of like what the optimal play would look like and then how this would happen. Okay, so I'm thinking that if there's an exclamation mark on the left and right side, like Bob can always just pick the same thing to cancel that out, so then we keep the numbers the same. So I think what you want to do is you want to just do this. And now this is like the real game. So this is 14 over here. And this is 5, and we have 2 things. Yeah, so basically like as long as Alice can get this above 14, then Alice wins and she can. Okay. So I think that's kind of how we do it. Now the question is, like, so basically we're going to have one side of exclamation marks and another side with none, and then we'll have values. So let's look at the scenarios. So if no exclamations, then just return left equals right. All right, that part's pretty easy. If there are exclamations, like let's say the left side is actually bigger. Like let's say we have 5 and a 5 or something. Then we know for sure that like Alice wins here. So if exclamations on left and left already bigger, Alice always wins. So now the last one is if there's exclamations on the side that's smaller, how much smaller does it have to be is the question. So clearly, like look, let's say we have no numbers on the left, we just focus on exclamation. So if we have look at this. Okay, so I wonder if it's like exclamations need to add up to 9 or something. Like let's say we have 9 and 9, and we have this. Then what would happen? Okay, so if there's only one exclamation, whatever number this is, Alice always wins. So Alice wins here. Let's actually, well, I'll do a timer for next ones. Okay. If there is, so which one did the Bob win? Bob always wins with this one, right? Or let's see. Oh, Bob always wins here, right? So yeah, so we have what do we have? We have the 329 on the left and the 5. So we have basically a 9 here and then 2 exclamations here. How does Bob always win? Is that correct? Let's see. 11, 14, 5, 9. Yes, this is 9 and 2. Okay, so Bob can cancel out whatever this is. And then Alice, so there's 14 here. And then there's a 5 here. So how does Bob, let's just do this one here. So let's say we have 3, 2, 9, 5. Okay, so if Alice just goes 9 and Bob goes 9 as well, assuming what we said is true. So then basically we have this left. And now, yeah, Bob can Bob go 0? Oh, you can place it 0 to 9. Okay. Yeah, so, okay, so 0 to 9 makes sense. Okay. So basically it comes down to this, right? Like, for every 2 exclamations, I think, they have to be equal to 9 or something. Is that right? Like, what if this was 5? Then that wouldn't work because that would be too small. Yeah, so basically, every exclamation maybe can do, like, okay, what if this was bigger? If this was bigger, then Bob would lose 2, right? If this was like this, Alice can just pick 0. So I think every 2 exclamations have to be divisible by 9 exactly. And if we have 1 exclamation, then, like, if we have an odd count, what would happen? Like, if we have, so 1, I think Alice just always wins. Because Alice can just pick, like, a number that Bob, yeah. So is that true? So, like, if we have an odd number, Alice always wins. No matter what we're trying to get. Yeah, I think so, because, yeah, so that's another one. So, odd number of exclamations, Alice always wins. Because Alice can just, like, pick last and pick something that doesn't match. So it has to be even number and number of exclamations. Number of exclamations. So every 2 exclamations have to be a 9, basically. Yeah, because then no matter what Alice picks, Bob can just make it a 9. So how would we write that? So number of exclamations over 2. Like, yeah, so let's see. If we have 10 exclamations, we need to be like 45, basically, right? So number of exclamations, I guess number of exclamations times 4.5 has to equal the right side. Yeah. Because if it's smaller, like, if we try to get like 8, then Alice can just pick 9. And if it's bigger, then we can't do it. Okay. So I think this is what we need. So let's go with all of this. So let's get like a left count, right count, or we can go like, I guess, yeah, Alice, like Alice total, Bob total, and then Alice, what do we want to call this? Cares or something, or question marks? Yeah, let's call it chars. Bob chars. All right, we'll make all these 0. Cool. All right, so then we can go through this. So, yeah, and this is always an even array. It has to be, right? Even, okay. Okay, so then for, whatever, range, length nums. So if it's length 4, we want to go, let's see, 0, 1, yeah, 2, this, okay. Yeah, okay. So this is the Alice side. And then, yeah, so if, let's see, if num, so this is num I is exclamation, then Alice total, Alice, or this is actually Alice characters. Otherwise, Alice total into num. All right. Now same for Bob. Actually, we can even do. This is fine. We can do it in one loop, but we'll just do it in two. Okay, so the blah. In fact, we don't even need. Oh, whatever. It's fine. Who cares? This is fine. Okay, so length nums over 2 to length nums. All right, so same exact thing. Yeah. Okay, so if it's exclamation Bob, right? Bob total. Okay. So I guess what we want to do first is we want to like take these characters and set one of them to 0. So we can do that. So if Alice characters is greater or equal to Bob characters, Alice characters minus equals, and Bob characters is 0. Okay. Else, other way. All right. So then we need to figure out these cases. So if there's no exclamation, so yeah, I guess if, let's see. I guess we need to figure out, yeah, we don't really care, like for the characters and the total, really, well, all we need to know is like what side the character is on, but yeah, I guess we can do each one of these cases. So if not Alice characters and not Bob characters, return left equals right, or whatever this is. Alice total equals Bob total. I guess not equal, right? Because Alice loses if they're equal. So, all right. Okay, so that one's done. And now let's walk through what this is gonna look like. So essentially, one of these is gonna have characters. So I guess, if we can do like if Alice characters. I mean, yeah, it doesn't really matter what side has the characters, honestly. So we can definitely clean this up as well. Yeah, so we can definitely clean this up. So let's figure out the difference as well. Yeah, we want the difference, right? So we want to kind of do the same thing here, and we can copy this. It's fine. Okay, so if Alice total is greater than or equal to Bob total, then Alice total minus Bob total, and Bob total equals 0. Yeah, I'm thinking, honestly, yeah, the way to do this would have just been calculate the left side only or something. Yeah, but whatever, it's fine. Okay, so other case, this. So this is just Bob total minus Alice total. And then Alice total. Okay. All right. Okay, so yeah, we basically just need to figure out like, yeah, we just need to change this into a variable because this is dumb. Okay, so I guess we can just basically add them together essentially, but we need to know what side we're on actually. How do we do that? We don't. We also, now that I noticed, like, well, actually it doesn't matter, fine. Yeah, so I guess the other case is if now basically the Alice is the left technically, so if we have characters on the left, then and the left total is bigger already, then we just return Alice. So if Alice total and Alice characters, or Bob total and Bob characters. So basically like the bigger numbers on the same side as exclamations, then Alice just always wins. Right, so now we have the characters and the total, and we need to figure out that diff. So we can just say characters equals Alice characters plus Bob characters now, because this is just added. Total equals Alice total. All right, so we just need to return characters mod 2. So it has to be an odd. So actually, so I guess we're thinking about Alice. So Alice wins if it's if it's odd, or characters times 4.5 does not equal the total. Let's see what we get. All right. Yeah, this definitely needs to be cleaned up a lot, so we'll do that as well. And then this is just all correct now. Well, hopefully. Okay. Ooh. 1 true. How do we return a 1? Where do we return? Output 1. Characters mod 2. I guess. Well, oh, I see. It'll do 1. Okay. Should be fine though. Okay. Alright, definitely need to clean this up. This is terrible. Okay, so how do we clean it up? So we can have the total being an array instead. Like we can have a left and a right side. So that's one thing. We can just go like this. Characters as well. Alright, so if this is true, then this is just the other way now. 0. Sorry, characters 0. Else. This is total 0. We can add this in here. Get rid of that. We can also just do like Alice num, a num equals num I. Okay, there we go. Copy all that. Okay. Bob equals num I plus nums 2. Okay, if bnum blah blah blah. Alright, so that is good. Now let's do, so the right side is going to be, yeah, honestly it doesn't do with Alice and Bob, it's just the side. Okay, so characters or totals. 0, 1. Okay, so now we need to do basically, let's see, how else can we simplify it? So we need to figure out like what's the character and what's the side. Yeah. So I guess, I mean, this is not going to be that much cleaner, to be honest. So if this is just a 0. Okay. We could also, what we could actually do to make it cleaner is we can just use like a positive and a negative number. That would make it a lot better. Yeah. That's way better. Okay. So we can have just a positive and a negative number, and positive will be like the right, negative will be the left. Yeah. So this will just be care. So yeah, so negative will be the left. Otherwise, it'll be the other side. Still a minus. And then we just do the opposite. Okay. All right. Now, a lot better. And now we don't need like any of this. So we don't need that. We don't need this. We don't need any of that. Okay. So now we know like what side we're on. So basically if Alice, so I guess what are the cases here? So the case is, let's see, Bob total and Bob characters. Okay, so if they're both on the same, this is the case where they're both on the same side. We do also want to check if the characters is 0. If not characters, yeah, so if not characters, return total equals 0. So that has to be the case. Total is not equals 0. So that's the no characters left. Okay, what if there's no total and there's characters? That's fine because the total will just be 0, so that's handled. So if they're on the same side, so how do we handle the same side? So I guess, yeah, so if the total is 0 and we have characters, then Alice always wins. So if not cares, if not total, the Alice always wins no matter what here. Yeah. Because we have to have characters, otherwise it'd be this case. Okay. So now we just have to check the same side. So we can go if total times characters. So essentially, if they have the same value, it'll be positive. So we can do that as well. So if total, if they have the same value, it'll always be positive. It'll be positive times positive or negative times negative. It's greater than 0. True. All right, get rid of all that. Characters mod 2 equals 1. And the characters, so this would just be like absolute value or something. Because who knows what side we're on. Sure. Let's see how we did. Okay. Definitely cleaned it up a lot. Cannot access cares. Cannot access. Total. Let's see. Oh, this is Benum. Yeah. Okay. Nice. Okay, I'm pretty happy with that. Yeah, so the main takeaways from this one is to realize like how the game works. So normally for these kinds of games, what you want to do is you want to just have a bunch of examples. And then from the examples, you can kind of try to figure out like what's optimal and what doesn't matter. And so you can recognize that like, okay, if there's question marks on both sides, whatever Alice picks, Bob can pick. And yeah, there's no way Bob can like increase his total too much on one side because Alice can kind of do the same. And Alice can just kind of pick what Bob can pick. So yeah. And then also recognize like the odd number of question marks makes sense because Alice picks last. And there's no way that Alice can pick like any number she wants and they'll all give you the same result. And then for even, yeah, just figure out, I guess, like what's the range we can have. And so as long as the 2 question marks are divisible by 9, no matter what Alice picks, Bob can always have a sum of 9. But that's the only sum Bob can consistently always have no matter what Alice picks. Because anything bigger, Alice can just pick a bigger number. Anything smaller, Alice can pick... Actually, there is nothing bigger. Well, actually, no. Anything bigger, Alice can pick a smaller number. And then anything smaller, Alice can pick a bigger number. Yeah. All right, so sum up linear... space. Do we have anything? I don't think so. Okay, cool. All right. So yeah, I'm going to be doing more of these, just like harder problems. I think it's more interesting, not just like, hey, here's a basic DFS or whatever. So yeah, let me know what you guys think about this problem, and I'll see you in the next one. And I'll link this as your track thing that I'll be using.